Hi everyone and welcome to this video. So in the last video previously we briefly spoke about what a computer is and what a computer language is and what a program is and why you should use a computer language like BASIC to program your computer. We also went through a few concepts that are involved in BASIC. The first one, which is variables, but we also introduced a bunch of commands like print, CLS, and input and rem. So for those who didn't see this video, I recommend you to go to the previous video, which URL is reported here, but it will also be in the comments below. So what are we going to talk about today? There are a few topics that we are going to discuss. The main one is going to be data-driven programs. So essentially we are going to introduce the concept, what is a data-driven program, why we will need that. And then through examples we are going to build an understanding of what a data-driven program is and how we can get a program to do the things that we want depending on the data that we have at hand. To achieve this, we will introduce a few new commands that are implemented in BASIC, and the commands are reported here. The first one is going to be the if-then-else command along with ELSEIF. Then we are going to discuss a little bit logical operators, which are very important in order to make your data-driven program behave the way you would like it behaves. And then we are going to go through a few other commands that are very important, which are while-wend. Then we are going to introduce another bunch of loops, such as do loop until and do loop while. And then the for next loop, which is extremely important in any language, and no exception, it is very important in BASIC too. And finally, we are going to go through the statement select case, which is very important in many languages. So it's important that we understand this statement. As usual, I want to thank you all for being here today, for continuing to encourage me, for continuing to subscribe, to share those videos with others. I really appreciate this. Thank you so much for encouraging me. So what is a data-driven program? What example can you bring to understand what this thing is? So far, the programs that we have developed are based on very simple commands like print, CLS, and input, and these kind of things. And the programs that we have been developing so far are very linear in a way. What do I mean by that? I mean that even if we change the data that we are processing, the program is going to behave more or less in the same way. We can make operations on variables, for example. We can do all sorts of operations. We can print the value, the results of those operations, but we cannot really change the behavior of the program depending on the result that we find. So for example, if we have a result that is positive, we would like to print that the result is positive. We don't know how to do that yet. So a data-driven program is exactly that. It's a program which behavior can change according to the result that you get or according to the flow of information that you get in the program. So it means that depending on the data that you have at hand, the behavior of the program is going to change. So that's why now we are going to start with a few new commands, and the very first one that we are going to introduce is the if-then-else command. With the if-then-else command, you are going to see this is going to be the very first command that we can use to control the behavior of a program depending on the data that we have at hand. So let's start with this if-then-else statement, and then we will introduce the else-if. The very first thing we are going to do is we are going to hit the new button here so we can start from scratch. And let's now let's try to implement a program where essentially we can understand what if-then-else can do for us. So an example, let's introduce a concrete example. Let's suppose that we have a variable which name is x, and this variable x has a value, and this value is a number. we want the value of this variable to be printed on the screen, but then depending on the sign of the variable, we want to have a different print on the screen. So let's suppose that x is positive, we would like to print x is positive, or if it's x is negative, we would like to print x is negative. So essentially, we want to have the behavior of the program depend on the value of the variable itself. So let's write this example very concretely to see what I mean. So let's call a variable x and let's assign a value, let's say 1.5. And now what we would like to do is to print the value of x. So the first thing that we do is this, and no big deal, we know how to do this. But now we also want to have a specialized print on the screen. So if x is positive, which is the case here, we would like to have something like this. We would like to write x is positive. We would like to see this message on the screen. But now, as you can see, if I change the value of x and I put minus 1.5, we still have this print here that says x is positive. So the only choice that I have is to change it, and to change it in a way where print now says x is negative. So this is not exactly ideal, so we have to find a better way. This is why we want to use the if then else. So the very first thing that we are going to say here is that if x is bigger than 0, then print x is positive. And we close this if statement by typing an if, just like that. So now if we do this, we can try to run it, and you are going to see what happens. So if we run it, now you see on the screen, the program is saying x is positive. So now let's try to change the value, and let's say that x is negative. So let's do x is equal minus 1.5, and let's rerun this program. So now what we see is the value of x, which is minus 1.5, but there is no other message. So what actually happened here was the following. The program went here after a while and realized that if x is bigger than 0, it has to print this. But x is minus 1.5, which is not the case, so it didn't print anything like this. It didn't print x is positive. So can we do something slightly more sophisticated, for example, and write x is positive when it is positive and x is negative when it is negative? And the answer to this question is positive. We just have to use the command else. So if we do like this now, and we add this new command x is negative here, what we are going to have is the following behavior. So the very first thing that the program is going to do if we run it is that it's going to assign this value to x, which in this case is minus 1.5. Then it's going to go through this new command here, which is print x. So it's practically going to print the value of x on the screen. But then here something more sophisticated happens. So now this is the data-driven part of the program. What is going to happen is the following. The program is going to check if x is positive, which in this case means if x is bigger than 0. And if this is the case, it's going to enter here and print this message. But since this is not the case, what the program is going to do is going to go through the else statement here, because x is not bigger than 0, and it's going to print the message that we find here, which is x is negative. So let's try to do this and let's see what happens. So if we run this program now, let's see what happens. And as you can see now, the program is showing the value of x, which is minus 1.5, and then it's printing x is negative. So in practice, what we have now here is that the behavior of the program is changing depending on the value of the variable x. Let's try something different here. So let's remove the minus sign here and let's see if the program behaves correctly. So if we run it now, what we see is very simple. The value of x is 1.5 and the message that we get is correctly x is positive. So can we do something slightly more sophisticated than that? And let's suppose that now we want to check if x is bigger than 0 and check if x is smaller than 0, and then we also want to check if x is exactly 0. So how could we achieve that? And there is a very simple way to do this. In practice, this is what we are going to do. We are going to use the ELSEIF command and do this. So what we are saying here now is this: if x is bigger than 0, then print x is positive. And then here we say else if x is smaller than 0, then print x is negative. And now we can add a new else here, which does not correspond to x bigger than 0 and which does not correspond to x smaller than 0, so it corresponds exactly to x equals 0. And now here we are going to put this message here: x is equal to 0. So if we try to run this program now, we are going to see how it behaves. So if we leave the value for the variable x as it is, so x equal 1.5, this is what we get. Let's run it. What we see is what we expected. The printed message is x is positive. So if we now try x equal to minus 1.5, same thing here. We run it and we obtain the message x is negative, which is correct. So now let's try something more interesting. Let's set x equal to 0 and let's run it. And now you see we get x is equal to 0, so we get the right message. So now I think with this very simple example here, you guys have understood why and how we can use these if then else commands and else if commands to achieve something slightly more sophisticated than what we could get in the previous video. Now we can start to think of data-driven programs, because practically through this statement we can make the program behave differently depending on the data that we are treating or the data that we have at hand. So let's introduce now the logical operators, and without going through very abstract concept, let's see through examples what these logical operators are. So in practice, what we have seen so far is that by using the if-then-else construct, essentially we can obtain a program that is data-driven, which means that the behavior is going to change according to the data that you are treating. But can we do things that are slightly more sophisticated than what we got so far? For example, what if we would like to check if a variable, or let's say the value of the variable, stands inside a range or not? So we have to use logical operators for that matter. So let's keep part of this program as it is. So we still assign a value for the variable x. Let's say we assign the value 0.5 this time, and let's say we print the value. But then we want to check if the variable or the value of the variable belongs to a range. And let's say that we want to check if x is inside the range, and the range is 0, 1. So the way we are going to check this is by using the if command again, but in a slightly more sophisticated way. So the very first thing that we are going to check is that if x is greater than 0, but then we also have to check that x is smaller than 1, because we want to check that the value of the variable x is in the range 0, 1. So we add now these logical operators, which is and then we say x smaller than 1. And then we can add then, and we can say print, and we can say x belongs to the range, let's say 0, 1. And now, just to make things slightly more sophisticated, we can add else, and if we enter in the else statement here, we are going to say x does not belong to this range. And we conclude everything by and if. So now if we run this program by using this new logical operator that we have introduced here, this and, this is what the program is going to do. So the first thing, a value is going to be assigned to the variable x, which in this case is 0.5. Then the value of the variable x is going to be printed on the screen. And then we enter here this if statement. So the way it works is more or less like English. The program is going to check if x is bigger than 0 and x is smaller than 1. And if this is the case, then this message here is going to be shown on the screen. If this is not the case, then a different message is going to be shown on the screen. So let's try to run this program and let's see what happens. And as you can see, the value of the variable has been shown, which is 0.5, but then the print message is x belongs to the range 0, 1, which is correct because the value 0.5 definitely belongs to this range. So the program is behaving correctly. One thing that I have noticed though is that we could have put a comma here, so I'm going to do this. And then here, rather than say to this range, we are going to say to the range 0, 1, so that we have a better message. So if we now, let's say, we add a sign here, and we say that x is equal to minus 0.5, what do you think this program is going to do? So if we run it, the very first thing that it's going to do is that it assigns this value to the variable x, and then it prints its value on the screen. And then, as usual, it's going to check if x is bigger than 0 and x is smaller than 1, which is not the case because now x is negative, so it is smaller than 0, and this condition here is not valid anymore. So what the program is going to do is going to enter the else statement here, the else construct here, and it's going to print this message, which is x does not belong to the range 0, 1. So let's try to run it and let's see if it works. And it does work as expected. So let's try now something different. Let's say that we still assign a value to the variable x and we still print the value of the variable x on the screen. But now this time, rather than checking if this variable is inside an interval, we want to check if it is outside the interval. And to keep things simple, we still want to have the usual interval, which is represented by 0 and 1. So we want to check that x is outside this range. So the way we do this is we still use the if statement, of course, but this time we want to check that x is smaller than 0 or x is bigger than 1. Then, if this is the case, we write, okay, something like outside of range. And if this is not the case, then we print inside the range. And we close this if statement by introducing an if. So if what we are doing now is that we have introduced a new logical operator, which is or. So this behaves differently than and this behaves more or less like or in English. So it means that if we run this program, this is what is going to happen. The first thing is that the program assigned the value 0.5 to x, and then it prints its value on the screen. But then it enters this if statement, this if construct here, and it checks if x is smaller than 0 or x is bigger than 1. And if one of these two conditions is valid, then the program enters this part of the program here and print it outside of range, which is the case because if the value of x is smaller than 0 and it's bigger than 1, in practice it means, or it is bigger than 1, it means that in practice it is outside of that range. If this is not the case, then it is inside the range. So let's run this program and let's see what happens. And as you can see, it says inside the range because 0.5 is definitely in the range 0, 1. So let's try something slightly different, and let's say that now x is equal to minus 0.5. So if we run this program, of course what is going to happen is that it's going to enter at some point this if statement here, and it's going to check if x is smaller than 0 or x is bigger than 1. And of course x is smaller than 0 because x is equal to 0.5. So the program is going to enter this part here and it's going to print outside of the range. Let's try it. And as you can see, the program behaved correctly and it has written outside of range. So this is a way to introduce another operator, logical operator, which is the OR operator. And finally, we can introduce the last operator, which is the NOT operator, which essentially is the negation of a condition. So let's say that we have this condition here that we are essentially checking, and we are checking if x is smaller than 0 or it is bigger than 1. If we use the NOT operator like this, for example, what this NOT operator is going to do is that everything that is in here, which is the condition that is being tested, it's going to be negated. So when this condition is true, because we have a NOT, now this condition with the NOT included becomes false. But if the condition inside here is false and we use the NOT operator here, then this condition here is true. So it means that now, because we have introduced the NOT operator, we have to change the print that we have in here. So in this particular case, because we are just negating the conditions, we have to invert inside with outside. And let's run it and see if it works. So let's suppose that x has the value minus 0.5 and we are checking that the variable is inside the range 0, 1. So let's see if this works. If we run it, this is what we are going to get. So we obtain outside the range, which is correct because minus 0.5 is definitely not in the range 0, 1. But if we change now the sign of x and we assign it equal to 0.5 and we run the program, this is what we get. And as you can see, now the program says correctly that x is inside the range. So now, because of this very simple example, we have understood that the NOT operator is essentially a negation, and it sets everything that is false to true and vice versa. So far we have introduced the if then else statement, which is a very powerful one, which also allows you to create data-driven programs. But in a way it's not very sophisticated because you are just checking something once, and let's suppose that you want to check something many different times. Let's say that you have a variable which value is going to change during the program, while the program is running. How can you check this many times? So we have to introduce the concept of a loop. And the way we are going to do this is in the following way. We are going to start to introduce the following loop, which is the while-wend loop. This is not the only loop that we can create in BASIC, but this is definitely one of the easiest one that one can understand. So we are going to start from this. And the way we are going to do this is in the following. We are going to create an example where we set the value of a variable to 0. And then what we want to do in the program is we want to have this variable changing value in time, so increasing, and every time it increases we want to print its value. But then we want the program to stop when the variable has a value that is bigger than 10. So the while-wend construct is definitely the best way to go in this way, or let's say it's the simplest way to go. And in practice, this is what I have written on the screen. So let's see together what this program will do. And the very first thing, if we run it, is going to assign the value 0 to x. But then it's going to enter this structure here, this while-wend, which is now a loop. So this thing is going to be repeated many different times. And how does it work? So in practice, you can read this as it were, English. So what this loop is saying here is that while x is smaller than 10, do the following thing, which is add 1 to the value of x. So this is how we do this. So we assign the value of x equal to the previous value of x plus 1, and then print the value of x on the screen. Now here it reaches wend, which means that it goes back to while and it checks if x is more than 10. If this is the case, it continues to go through this block of commands here until x smaller than 10 is not valid anymore. So very concretely here, what is going to happen is this: x is equal to 0 at the beginning, and then we enter this loop here. What happens is that the computer checks if x is smaller than 10, which is the case because x is equal to 0. So x now is going to be added 1, so now the value of x is 1. And what it's going to do is that it's going to print the value of x, which is now 1. So we are going to see 1 on the screen. Then we reach wend, which means that we go back to while. Now x is equal 1 and x is smaller than 10. So we enter again this block of instructions here, and x is added 1 again. So x now becomes 2. And the value 2 goes on the screen because of this print command here. We reach wend, so we go back to while, and now x is equal to 2 is smaller than 10, so we go back to this block of instructions, and so on and so on and so on, until at some point x here is going to be equal to 9, which is smaller than 10, so we enter this block here, and now x becomes 10, the value 10 is printed, and then we reach wend, which brings us to while, but now x is equal to 10, which is not smaller than 10. So we don't enter anymore in this block here, and what the program is going to do is going to end everything because there are no other instructions. So let's try to run this program and see what happens. And as you can see, we have the numbers 1, 2, 3, 4 up to 10 exactly like we expected. So for this very simple example here, we have understood how to use the while-wend loop. So can we do things slightly more sophisticated than that? Are they loops or loop constructs that can allow us to do more than this? And the answer is positive. We are going now to go through this new statement, which is called do loop. And the way we are going to do this, there are two variants of this. There is the do while loop, and we also have the do until loop. So we are going to implement two different examples using the while and the until. So let's start from the while. And the way we are going to do this is we are going to implement exactly the same example as before, but we are going to use the do loop while construct. So if we add a while here and we say do while x is smaller than 10, and we do the usual here, which is x equal x plus 1, so we update the value of x by adding 1 to it, and then we print it. So this program is going to behave the following way if we run it. The very first thing it's going to do is to assign the value 0 to the variable x, and then we enter this do loop construct. So the very first thing that is this do loop is going to check is that x is smaller than 10, because in a way what it's going to tell you is that everything that is between the do and the loop, so this block of instructions or this block of commands, is going to be run only while x is smaller than 10. So it means that in practice, the program is going to check every time if x is smaller than 10, and if this is the case, then these commands between do and loop are run. So if we do this now, if we use this program and we run it, let's see what we get on the screen. And as you can see, the behavior is exactly the same as before. So we have the numbers from 1, 2, till 10. So now we can do something slightly different, and we use now the until. So until is of course different, and it means something different even in English. So even the behavior of the program is going to behave differently. So do until this time means that everything that is between the do and the loop is going to be performed, but until a certain condition is valid. So in this particular case, let's say do all of this until x becomes bigger than 10. So let's try this and let's see what happens. You will see that the behavior is more or less what we expect. So what we got here is that we have the numbers 1, 2, 3, 4, but up to 11 this time. So what happened here? What the program has done this time is the following. The very first thing that it did was to assign the value 0 to x, and then it entered here. And the value of x was 0, so 0 is definitely smaller than 10, so it is we are not in the condition that x is smaller than 10. So what it did was the following. For x equals 0, it added 1 to x and it printed it, and then it went back to the do until here, and now the value of x was 1, so until 1 is bigger than 10, you understand we can 1 is definitely not bigger than 10, so it continued to add another 1 to the value of x, so now x becomes 2 and it prints 2, and so on until at some point x becomes 10 here and it prints the value of 10, and it goes back to this do until. But as you can see, 10 is not bigger than 10 because 10 is equal to 10. So what the program is going to do, it's going to go inside this block here of instructions again. It's going to add 1 to the actual value of x, which is now 10. So now x becomes 11 and it prints the value of x. But now when we go back here to the do until x bigger than 10, now we are in the condition that x is equal to 11 and 11 is bigger than 10. So this block of instructions here is not going to be repeated, which means that the programs end. So for this very simple example here, we have understood the difference between the do while and the do until. There is also something very interesting to mention here. So if we add the while and the until right here, close to the do, this condition here is going to be checked every time at the beginning of the loop. So it means that before we run or we perform these actions here, we check if the condition is valid. So depending on if it is an until or if it is a while, it's going to perform this block or not. But what we know for sure is that if we put the while and the until here close to the do, essentially these conditions are to be checked at the beginning of the loop. But this is not the only way we can have a loop. In practice, we could also do something like this, where we add the while or the until close to the loop rather than close to the do. And then, let's say, we add the condition here. So what the program is going to do this time is different. So rather than going and check the condition at the beginning like we had here, it's going to check the condition right after, right at the end of the loop. So it means that first of all it's going to perform these operations here, and then, and only after it has performed all of this, it's going to check if this condition is valid. The same applies for until, if you don't want to use loop, but you get the main idea. So in practice, if you need to check your conditions at the beginning of the loop, you assign them close to the do. And if you want to check the condition at the end of the loop, then you add those conditions close to the loop. So we are going to see now a different loop that is very interesting and very common in BASIC but also in other languages, which is the for next loop. So let's remove this part of the program and let's try something different. Actually, we are going to remove this part as well. Let's suppose that now we have a variable I and we want this variable to have the values between 1 and 10. And we want that it has all these values one after the other. So what I mean is we would like to have some sort of loop where essentially an index or a variable takes different values that we assign to it. So to make things concrete, let's say, how do we do this in BASIC? So the first thing that we do is we type for, and let's say that the variable that we want to change value is I. And the initial value for I is 1, and the final value for I is 10. So if we write something like this, what we are going to get is a for next loop in BASIC. And what we get here is, just to make things more concrete, we add a print here just to see what the program is going to do. But before we run it, let's try to understand in words what it would do. So with the for loop that you are defining here, the very first thing that happens is that it's going to assign the very first value that you are assigning to I, so this variable, and the very first value is going to be 1. And then what you are saying here is that the value of I is going to go from 1 to 10. So it's going to take the value 1, 2, 3, so on until we get to 10. And then every time that a new value is assigned to I, the block of instructions that you find between for and next, which in this case is just one simple command print, it's going to be performed. So essentially this becomes a loop where in practice we assign an initial value for a variable, and then this value is updated every time the program gets the command next. So in this particular example, I is equal to 1, and then we print 1, then we reach next, which means that now I becomes 2, we print I, which is 2, and now we reach next again, which means that I now becomes 3, so we print 3, and so on and so on. But let's run it just to see what happens on the screen. And as you can see, the program behaved correctly, so as expected, it printed the values of the variable I, and the variable I got the values between 1 and 10. But let's try to do something slightly more sophisticated just to give an idea of what one can achieve with the for next loop. So let's say that we are interested in showing I, but we also want to show the square of I. So this time we print I, but we also print I times I. So if we run it, this is what we get. And correctly, as you can see, we have the variable I that takes the values 1, 2, 3, and so on until 10, and then close to each number we have the correct square of that number, which is what we would expect. But now let's suppose that we want to go from 1 to 10, but we want to use a step which is equal to 2. So it means that we start from 1, and then the next time we update the variable I, it's not going to take the value 2, but it takes the value 1 plus 2, which is the new step that we have defined here. So what we expect here is that we are going to see 1, 3, 5, and so on until we reach 10. But of course, since you will see that 10 is not there because 9 is the last number that we can reach through this for next loop. And that's exactly what you see on the screen as expected. So for this example, we also have understood what the for next loop can do. If you are a beginner, so I would definitely suggest you to go through other examples to understand this for next loop very, very well. This is a very important one in any language that one can think of. So the last statement that we are going to see today is different from the others that we have seen so far, and this is the select case. So how does it work? Let's go through this in through a very simple example. Let's suppose that we have a variable x which value is 1, and we are interested in checking the value of x, but not in a very general way. We are just interested in a few cases, and let's say that these cases are x equal 1 or 2 or 5. So there is a way to do this. Of course, one could use the if then else, but there is another way also to achieve this. And this is the select case construct. So how do we do this in practice? So the very first thing that we do is we introduce this select case x, which means that in practice we are going to go through a few examples or through a few cases which involve the variable x. And then we are going to say what are the cases that we are going to check, which are case 1, case 2, and we say case 5. And then here we close the select case construct by introducing and select. So here now what we do is the following. We add the commands that correspond to the cases. So let's say that in the case number 1, so if x is equal to 1 in practice, we want to print the message 1, but if case is 2, then we want to print the message 2, and if x is equal 5, so case 5, we want to print the message 5. So in this particular case, if we run this program, this is what is going to happen. The very first thing the program is going to do is that we assign the value 1 to the variable x, and then we enter the select case statement, which involves the variable x. So what the program is going to do is going to go through every single case and check which one is valid. And in this particular case, well, x is equal to 1, so it's going to print the message 1 or the string 1. So let's see if these actually work, and let's run the program. And as you can see, the only thing that we see on the screen is the message 1, which means that the program worked as expected. So for today we have introduced many different statements. As always, I warmly suggest beginners to go through this video once again, many times, to stop everything whenever it is time, to copy these examples, to run them by themselves. If there is any comment, any question, I would be more than happy to take them in the comment section below. And as always, I thank you very much for your attention.